Okay, let me give you guys some more practice. So here, a car initially at rest, it will accelerate 7 meters per second. So this here is just another way of saying meters per second squared. So you can say meters per second squared, or you can say meters per second. Both the same thing. So here, a car initially at rest, it accelerates 7 meters per second squared. Um, what will be the speed of the car after traveling 200 meters? So that's a question. Find out the speed of the car after traveling 200 meters. So try to think about this. Draw your three graphs just so that you can get an idea of what's going on inside your mind. So the three graphs: acceleration time graph, and then you got your velocity time graph. Oh, in this problem, for this problem only, we are only concerned about the car going in one direction. We don't care about the car. Well, the car's not going to go backwards. We only concerned about the car going in one direction. So you could change this v into speed. You could change this graph into speed time graph rather than velocity time graph. You can still use velocity, but you can use speed because we only concerned about the car going in one direction. And again, normally it's normally it's displacement time graph, but because we are only concerned about the car going in one direction, we can use distance time graph. Okay. Well, anyway, your speed. My point is because for this problem only, we are only concerned about the car going in one direction, so we can use speed and distance as opposed to velocity and displacement. You are allowed to still use velocity and displacement. It doesn't matter. Okay, so your acceleration time graph for this problem will look like this, with this being 7, and then your speed time graph could look like this, and then your distance time graph will look like this. So try and but by you drawing these three graphs, you got to somehow find out what you had to find out, if that makes sense. So the question is, what will be the speed of the car after traveling 200 meters? Um, Another way of thinking about this is like this. You're on top of the building here. Let's say you're on top of the building. You drop a cannonball here. Let's say you're on a you're on a planet that has an acceleration of 7 meters per second squared. You see, this cannonball accelerating downwards at 7 meters per second squared is the same as you sitting in a car, but your car is accelerating vertically downwards here at 7 meters per second squared. It's the same thing. So this distance here is the same as the distance here, 200. So you could actually, well, when something's free falling, you should visualize something like this: h equals g t squared over 2. Well, your car here, the acceleration of your car is really like 7 here. So your car is like this, 7, something like this. And the distance traveled, well, the distance traveled is 200. Well, anyway, do what I've given you so many clues here now. Find out the speed of this car after traveling 200 meters. So press pause and have a go. Okay, so just quickly sketch your three graphs, just so that you can get an idea of what's going on. Okay, so your acceleration time graph will look like this. Your speed time graph will look like this, and your distance time graph will look like this. Okay, distance time graph. Now you see, this problem really translates to you having to find out here, a time here where if you have a distance time graph, the area underneath the time, the distance. Sorry, if you have the speed time graph, the area underneath the speed time graph represents the distance traveled. But in this problem, you've been given the area of 200 here, and then you've got to find out this height here, x here. So yeah, so this problem. Hang on, let me just redraw the speed time graph. Speed time graph. It will look like this. You see, it's asking you, well, don't forget, this here is y equals mx plus c, but m is here is the acceleration, so so is this. C is the intercept, which is 0. So this 7 here, the gradient of this line here is 7. Just bear that in mind. It's irrelevant, but know that the gradient here represents the acceleration. Well, anyway, the problem here is it actually boils down to you. Well, you're told that the area here the problem here translates to saying the area here is 200. So find out this level here. Okay, so basically you've got to find out a time where you where it would give you the area of 200 here. Well, this height here, well, you know the equation for this line is y equals 7x plus c, where c is 0. So it's basically y equals 7x. So you see, you've got to find out a time here where this area here is 200. So, well, let's just say this time here, let's put it into here. So the height here will be 7t, because you put the t into this here, and the equation of this line here is y equals 7x. So this height at time t, the height here will be 7t. Now the area, well, look at this here. This distance across here is actually t. So what you have to do is get t. Well, we're trying to work backwards here. We have to find out a t where the area of this triangle is 200. So well, let's do it this way. Get this length here, which is t, okay, and then you times the height here, which is 7t, and then we've got to divide it by 2, and then that equals 200. Okay, because the area of this thing is 200. So now tidy this thing up. If you tidy this thing up, it looks like this. 7t squared over 2 equals 200. So you working out backwards will give you t. Okay, so once you've got t, then you got to find, well, you got to put this into here, which is then you would times it by 7. That will give you this height here. Okay, that's what it boils down to. You see, what I'm trying to emphasize is that this bit here is a bit like your h equals gt squared over 2. So if I were to do this, I would just translate this problem as this. So you're on the top of a building, you drop a cannonball down here. Well, it's a bit like, well, I'm going to visualize it like this: a car here accelerating 7 meters per second downward. Now, this is like a car free falling on a planet that has an acceleration of 7 meters per second. So I'm just going to jump to this: h equals gt squared over 2. But this g here is our acceleration of the car. So h here is the distance traveled. Well, I know the distance traveled is 200. Okay, it's 200. So I'm just going to jump to this. So put 200 into here, and then the g in our car's case would be 7t squared over 2. Now remember our acceleration time graph, our distance speed time graph. We are trying to find out this t here. Once we've got this t here, we can just find out this height here, because ultimately we want to find out the height here, which represents the speed of the car. Okay, but at the moment we are just trying to find out the t here. Okay, so wait there. This is our distance time graph. Our distance time graph will look like this, which is y equals gt squared over 2. That's the equation of this line here. So basically, we are trying to find out the time here. Okay, so times both sides by 2, so that will be 400 equals 7t squared, and then divide both sides by 7. Calculator, hang on. Calculator. So 400 divided by 7 equals this. let's say 57.14 equals t squared, and then square root both sides. So hang on. So square root this would be 7.56. So the time it takes for this car to travel from here to here is the same as the car free falling from here, well, 200 meters. So anyway, the time it takes for the car to travel from here to here is 7.56. Okay, and let me clear this up. It's 7.56 seconds. But the thing is, we want to know the speed. You see, you've got your acceleration time graph, and then you've got your speed time graph. Well, because you know this, you know the time is 7.56. Then you can just put this 7.56 into this equation here. This equation is y equals 7x. So you can put this into here. So this height here would be 7 times this thing here, which is, hang on, well, just times 7 here, times 7 equals 50. Let's just round off to 53. So the speed here is 53 meters per second. Okay, so this is your answer, 53.